Welcome to Lab 1 Part 2, where we will cover the basics of Python. Before we start, we must first understand the syntax of Python. So first, Python is case sensitive. What that means is if you have a variable called myvar, all lowercase, that is different than myvar, all capitals. The same applies for calling functions. If you call a function called myFunction, which is lowercase, that is different than myFunction, which is all capitals. Python is also indent sensitive. What that means is that the number of spaces or indents is important. So here, if I add a space, we can see that we get an indentation error or an unexpected indent. So this means where and how many indents you use is important. Semicolons in Python are not needed. So if I say print hello, this is the same as print hello with a semicolon. However, if I have two lines of code that I would like to write in one line, semicolon can be used to separate the two lines of code, and you can write it in one line. Python is zero index. What this means is that when working with lists, the first element is at index 0. So to get the first element in this case, we would have to use the index at 0. Comments are lines of code that are not executed, but rather give context to the reader. In Python, to add a comment, use a hashtag followed by the comment. So nothing happens if I run the cell. The print function in Python can be used to display output to the user. To print a string, we can use either single or double quotes. So in this case, I use double quotes, which is the same as if I were to use single quotes. And there we see hello. The same applies for numbers, so if I wish to print 100, there we go, we get 100. Now, if we wish to print multiple values on the same line, we can separate them with commas in the print function. So if I wish to print hello on the same line as 100, we can just separate it with a comma. And then we get hello 100. Now we will cover some basic math operations. So for addition, we can use the plus sign. So 5 plus 3 is 8. For subtraction, we can use the minus sign. 5 minus 3 is 2. For multiplication, we can use the asterisk sign. 5 times 3 is 15. For division, we use the dash, so 5 divided by 3. Now if we use two dashes, we get integer division, which is the integer when we round down. So in this case, when we round down, we get to 1. We can also use the percent sign, so 5% sign 3, this gives us the remainder. In this case, the remainder is 2. When we multiply 3 by 1, that gives us 3, and then the remainder is 2. To use exponents in Python, we use two asterisks. So 5 raised to the power of 3 is 5 2 asterisk 3. To round in Python, we can use the round function. So round 1.3 would round us down to 1. If I wish to round to a certain decimal place, we can do that using comma and then the number of decimal places. Let's say 3 decimals. To get the absolute value in Python, we can use the ABS function, standing for absolute. So absolute of negative 10 gives us 10. Now moving on to some functions we can apply to lists. So now if we wish to take the sum of a list, we can use the sum function. To find the minimum, we can use the min function. And to find the maximum, we can use the max function. Values can be stored inside variables. For example, let's store the string hello world inside myString. We can do that by declaring the variable myString and set it equal to the value hello world. So now we can refer to that string using its variable name, in this case my string. And this is the same as if I were to use single quotes. The same applies for numerical values. So let's set a equal to 2 and then b equals to 3. Now we can go ahead and print a and b. Just like we did with values before in the basic math operations, the same applies to the variables. So we can do a raised to the power of b, which is 8, or a times b, which gives us 6. Lists can be used to store a sequence of values in order. So let's declare myList equal to an empty list. And then let's go and print that out. And we get an empty list. We can also declare a non-empty list, let's say 1, 2, and 3. And when we print out the list, we get 1, 2, and 3. If we wish to get the length of a list, we can use the len function, which will return the length of the list. In this case, the length of the list is 3. To add a value to the end of the list, so first declare myList.append, which is the function we wish to use, and then the value we wish to add to the end. So in this case 4, and you can see we get 1, 2, 3, and then 4 is the newly added value. So now to access the values in the list, we can use square brackets. So square brackets and then the index. So the first value, in this case 1, would be at index 0. The second one would be at index 1, and then the third one is at index 2. Matrices can be expressed as lists inside a larger list. So in this case, we have the first row 1, 2, 3, and then the second row is 4, 5, 6, and then the last row is 7, 8, 9. So if we go and print this out, we'll see that we get a matrix. To get the first row of the matrix, we can go matrix square brackets and then the row number. Let's get the first row, which is index 0, which returns the first row 1, 2, 3. To get the second value in the first row, we can use another square bracket and then index 1, which will return 2. If-else statements can be used to execute different sections of code based on if a condition is true or not. So let's use the if keyword to declare if statement and then the condition. So in this case, let's go true, and then we'll go and print if. And if that's not true, we go to the else, and then let's print else. In this case, since the if statement is true, we print if. If the statement is false, we skip this line of code and we go directly to the else. Now, if we have another condition to meet, we can use an elif keyword, and then if this condition is true, we can print elif. In this case, the first condition is false, so we go to the second one, which is true, and then we print this line. If this were false, we would go to the first one, this is false, this is also false, so then we go to the else, and then we print else. Now let's try the same thing using variables. So let's start by declaring a variable a equal to 100 and a variable b equal to 10. So if a is greater than b, we're going to print a is greater than b. And in the else statement, we can print just else. So in this case, 100 is greater than 10, so we print a is greater than b. Now if we switch this and we say a is less than b, we can see that this is false, and so we go to the else statement. Let's add another elif statement, and we say if a is equal to 100. In this case, a is actually equal to 100, so we run this line of code. Note that Python uses indents to declare what is and is not in the if statement. So anything that is indented here is in the if statement. If we are missing the indent, then we get an indentation error. If we have two indents, we also get an indentation error. To declare a for loop, use the for keyword, then a variable. In this case, let's use j, followed by in, and then range. So we will loop through the range from 0 to 5. And we can print out j, which is the variable that changes during each loop. As we can see, j starts at 0, it increments by 1 each time until it hits 4. If we wish to loop through a range, say 5 and 25, first declaring the lower bound, then a comma, and then the upper bound. These for loops can also be used to make a list. So if I have an empty list, we can use a for loop using I in the range of 5. So we go from 0 to 4, and we can add this to the list using append. So mylist.append, and we can append I. As you can see, we have 0, 1, 2, 3, 4 in the list. If we have a non-empty list, we can also iterate through it using a for loop. So let's say a non-empty list with values 3, 4, 5, and 6, and for I in my list. In this case, I is the element of the list, and through each loop, we will go through each of the elements in this list. And so during the first loop, I is 3, the second loop I is 4, and so on. Use the while keyword to declare a while loop followed by a condition. Let's say true, and then the code to execute. This while loop will keep running until the condition here becomes false. So this code will run indefinitely since the condition is always true. We can use the break keyword to stop a while loop from running. So in this case, the while loop will only loop once. Let's try this with a variable. Let's say I is equal to 0, and then while I is less than 10, we can print I and then add 1 to I. Let's make a list using a for loop of the value 0 to 9. So we start with an empty list, then we use for I in range 0 to 10, and we can append that to the list. Then go ahead and print my list, and you can see we have the value 0 to 9. In order to create this list, we had 3 lines of code. What if we can do this in 1 line of code? To do this, we will use list comprehensions. We can do this by first declaring the list variable, in this case my list, is equal to square brackets. And inside the square brackets, we can declare the for loop as well as what the elements are. So here, each element is just I, and then the for loop is for I in range 0 to 10. And then go ahead and print that, and you can see we get the same list. Nested loops are when one loop is inside of another loop. We can do this by declaring an outer loop, so for I in range 0 to 5, and the inner loop we can do for j in range 0 to 5. Let's go ahead and print out I and j. So in this case, we can see that for one iteration of the outer loop, in this case it's 0, we do one full iteration of the inner loop. So from 0 all the way to 4. Now this can come in handy when iterating through a matrix. So if we have a matrix, we can use a nested loop to iterate through the matrix. So let's do this by having an outer loop. So I in range from 0 to the length of the matrix, and an inner loop for j in range from 0 to the length of the first row in the matrix. And let's go and print matrix at I with column j. And now we have iterated through each of the elements inside the matrix. Let's say we wish to do the following operation. Now what if we want to do this 5 times with different variables? Well, we can go ahead and we can copy this out 5 times, switch out the variables, but this is very inefficient. So what if we could reuse the same code? Well, this is where user-defined functions come in. So we can use user-defined functions by declaring the keyword def followed by the name of the function, let's say my function. And then we have round brackets and the inputs. In this case, the inputs to the function are a and b. Everything in this indented block will be part of the function. So we can go ahead and indent this. And to call the function, we can go my function, the name of our function, and let's pass in the values. So 5 and 8, 5 for A and 8 for B. We can delete this and we get else. So if A is equal to 3, we get 3. So what if we want to return a value? So say instead of printing 3, we want to return a value. So we use the return keyword, return 3, and then if that's not true, we can return 0. And here we can set this to a new value, so the return value will be equal to C. And finally, print out C. We see that C is now 3.